You're multiplying polynomials here. You are multiplying this guy, 8k minus 3, that's a binomial because it has 1, 2 terms in it. And then you're multiplying it times 8k squared plus 3k minus 1, which has 1, 2, 3 terms, and that is a trinomial. Well, whenever you multiply a binomial times a trinomial, or a trinomial times a trinomial, you're going to use the distributive property. And what you're going to do is you're going to take this 8k and you're going to distribute it to each term inside the trinomial. So 8k times 8k squared, 8 times 8 is 64, and k times k squared would be a k cubed. Then 8k times the 3k would give you a positive 24k squared. And then an 8k times, I'm going to see this as a minus 1, as a negative 1. And a positive 8 times a negative 1 is a negative 8. And then, of course, don't forget the k. Now, that takes care of the 8k. Now, you're going to pick up the minus 3 because you've used the 8k. So I'm going to distribute the negative 3 to each and every term in the trinomial also. So negative 3 times the 8k squared is going to give me a negative 24k squared. Then the negative 3 times the 3k is going to give me a negative 9k. And then the negative 3 times the negative 1, a negative times a negative is going to make that a positive 3. Now I'm done with the multiplication, but I'm not done with the problem because I have some like terms that I can simplify. And let's see, the 64k cubed, there is no other k cubed, so that's still there. However, this positive 24k squared and this negative 24k squared, those cancel out, leaving 0k squared. So k squared is gone. And then you've got this negative 8k and another negative 9k, so altogether I have negative 17k. And then at the very end I have this positive 3, and he's all by himself. He has nobody to hook up with, so he just trails on the end. And that is my answer. That's how you do it.